Okay, in the second guided practice this week, we are going to do the Archimedes Principle problem. This problem is number 15 in the 8th edition Savage text, and it's number 6 in the new um, 9th edition of the Savage text. And the problem reads like this. Buoyancy is the ability of an object to float. Archimedes' principle states that the buoyant force is equal to the weight of the fluid that is displaced by the submerged object. The buoyant force can be computed by buoyant force equal the volume of the submerged object times, or the cross product of that and the specific weight of the fluid. Write a program that inputs the weight in pounds and the radius in feet of a sphere, and then outputs whether the sphere will sink or float. Use 62.4 pounds per cubic foot as the specific weight of water. And then the volume of a sphere is going to be 4/3 pi r cubed. Okay, I will start by creating a new project. File, new, project, console application, and I'm going to name this Monroe J. We'll call it chapter 3 dash, and if you're in the 8th edition, you'd put dash 15, or if you're in the new edition, dash 6. And that's just so you can look back on the problem later on if you do happen to review these. And remember that all of your projects are open. They're open game for the tests, so keep your projects and keep them organized. And I'll go ahead and put Archimedes principle. Okay, and I'm going to create a folder for this one as well, new folder. I'll call it the same thing. And in that folder is where I'll save the project. And here I'll say the user-defined radius in feet. Using namespace. Okay, I'll start by declaring my variables. And I'm going to create several doubles here, FB for the buoyant force, V for the volume, and then Y for that specific weight, also called specific gravity for our pre-engineering students. 62.4. And I'm going to create a variable for the weight of the sphere, so I'll just call it sphere pounds, and then finally the radius of the sphere. Now this program doesn't ask for this, but I'm going to go ahead and soup up the program a little bit. I want us to be able to run this program repeatedly and calculate the buoyant force for multiple spheres until the user says it's time to quit. So I'm going to throw in a loop, in other words. And so in order to exit out of that loop, I'm going to have a character that I'll call ANS for answer. And every time at the end of the loop, I'll ask the user if they want to calculate another sphere. And I'll go ahead and create that loop now. Sometimes I create the loop after I've written the program, so that's just kind of like adding an extra feature to it, giving you the ability to run the program over and over without having to relaunch the executable or recompile your program or rerun your program. So I'll do this while answer, and this will give us an opportunity to create a compound Boolean expression with some of those Boolean operators that you should have read about in chapter 2 and chapter 3 here. So I'm going to have this loop continue while the answer is equal to, and remember equal to is double equals. And I'm going to be testing for the capital Y as well as the lowercase y. Okay, so that statement, this is the OR, and the OR is the inclusive OR, which means if one or the other of these or both are true, then the whole statement evaluates to true. Now, obviously, a character couldn't be both capital Y and lowercase y, but in other instances, you might have there might be a test where the what you're testing for, maybe on this side it would be something different. If it were true, if you notice the truth tables at the beginning of chapter 3, the OR operator, if one or the other or both are true, then the whole statement evaluates to true. So this is just a way of creating a compound statement there with the compound Boolean statement with the OR. Okay, start by prompting my user. I'll ask them to enter the weight of the sphere in pounds. And notice I didn't do an inline there. I want them to be typing just to the right of this colon, which will appear after pounds there in the first line. I'll read their result into sphere pounds. And then we need another prompt asking for the radius. Okay, now that I have those two values, I've read those two values in, I can perform my calculations. I'm going to do the volume first, and the volume is 4/3 times pi, and I'm just hard coding the value for pi in here at 3.14. And then the radius cubed. And so there is a function in the math library that allows you to take a value to a power, but we haven't covered that math library yet. I think maybe we will in future assignments, but for now I'm just going to multiply the radius by itself 3 times. And then finally, the equation that you see in the textbook, buoyant force is equal to the volume, and the cross product of that and the specific gravity or specific weight, v times y. Okay, the problem in the text asks you to make different statements based on whether or not the sphere will float, and that's going to be determined by whether or not the buoyant force is greater than the weight of the sphere itself. So take a look at the instructions there. If you're in the 8th edition, the green Savage text, then it's number 15 at the end of chapter 3. If you're in the purple 9th edition, we're looking at number 6. It says, write a program. This is the last paragraph in that problem description. Write a program that inputs the weight and the radius of a sphere and outputs whether the sphere will sink or float in water. So this is going to be our first decision structure. So we've done loops, which is our repetition structure, do while. Now we're doing our first decision structure. And this is when you have lines of code that you may not want to be executed at all on a particular given run. It's dependent on some Boolean expression. So here what I'm going to do is I'm going to create an if-else statement. If the buoyant force is greater than or equal to the weight of the sphere, then the sphere is going to float. So I'm going to have an output here. This sphere could be used as a bobber. Okay, this is a single branch decision structure as is. If this is true, then this code will be executed. If this is not true, depending of course on the user input, then this code won't be executed. And that's the point of a decision structure, is to be able to perform some lines of code given a particular expression is true, and if it's false, then do something else. So lines of code that may or may not be executed is the point of a decision structure. And this is the dual branch decision structure now that I've added the else. So else, if that's not true, if the buoyant force is less than the weight of the sphere, then the thing's going to sink. So I'm going to have a separate cout statement in that instance. I'll say tie this sphere to Jimmy Hoffa. That's a little bit of a archaic reference. So it'll float in this case. If that's true, if that's false, then it won't float. I'm going to make a comment there. This is the dual branch decision structure. Okay, so that takes care of what the text is asking you to do. I'm adding this additional feature of being able to run the program over and over again. So I'm going to reprompt the user for reiteration, and so I'll say cout and I think I'll put an inline after these up here. I'm just kind of thinking ahead to what my formatting will look like. And these don't need inlines because when the user types the value and then hits enter, it will automatically go to the next line. Okay, these we need the inline, and then I'll ask the user calculate buoyant force for a new sphere, question mark, and then I'll instruct the user to type either yes or no, or y or n. And we are testing for both the lowercase and the uppercase y, although I'm just telling them to type the lowercase or the capital Y. And then we'll read that value into our A and S character. Okay. Let's run this and see how we do. Okay. Oh, it looks like maybe I have a space in between my greater than or equal to. There cannot be a space there. Okay, enter the weight of the sphere in pounds. I'll start with a 5-pound sphere, and the radius, I'll start with a foot radius. Okay, that one will float. Calculate the buoyant force of a new sphere. I'll go ahead and type Y, and it should continue again. Enter the weight of the sphere in pounds. So that one floated. I'll make this next one heavier and smaller. So I'll do 10 pounds, and then let's do 0.5 feet. Okay, that one still floats. Let's try this again. I really want to find a one that will be an anchor as opposed to a bobber. Let's try 100 pounds, and radius, how about 0.25? There we go. That'll sink to the bottom. Okay, and then if I type no, really you can type anything here, and as long as it's not Y lowercase or Y capital, it should exit the program. Okay, so that concludes this guided practice for Chapter 3. We've used both a repetition structure, the do-while loop, and then we've used our first decision structure, if-else. Happy programming, and know yourself.